We now talk about using diagrams to show validity or invalidity of arguments. And sometimes this is quite intuitive to use. So sometimes you can do a little quick drawing to get a good sense whether an argument is valid or invalid. But this is diagrams are not appropriate in some complex settings because it's going to be too many different possibilities. So and sometimes can be more confusing. And diagrams are not a formal proof. So using logic, writing words, deriving one from the other, that would be formal proof. Here's a summary of for the diagram. There are 4 possible relationships between two sets. The first one is all P's are Q's. Like for instance, all math majors are hardworking. So here we have actually two sets, sets P and sets Q. In this particular case, we actually also have two sets. One is all math major students, right? And the other set is hardworking students or hardworking people. So there are two different set of people, so P's and Q's. Now, how do we visualize or using a diagram to represent, to summarize this relationship? All P's are Q's. So oftentimes we create a circle to represent sets. So all P's are Q's. And if we use this to represent the P, sets P, and because all P are Q's, therefore P has to be inside the set Q, right? And now oftentimes we also put a dot, use a dot to represent a arbitrarily but particular element of sets P. So from this graph, we can see all, no matter where you draw a point from P, it's absolutely inside the Q. So this diagram represents all P's are Q's. So this is the first one. And of course, if I want to graph this particular statement using diagram, I'll say P is the math major, right? Math majors, like all students with math majors. And Q represents another set of hardworking people. So hardworking people. And then to represent all math majors are hardworking, I really have to show a dot, like draw a dot. This dot represents an arbitrarily chosen but a particular element, a student inside these sets. We can see that this dot is actually inside the hardworking these sets. Therefore, we can see that all math majors, they are hardworking people. Now, the second one is no P's are Q's. That means if you draw a P, sets P, and then put a dot to represent a particular element from sets P, and because no P's are inside Q, so we really have to draw Q so that P and Q do not overlap. So this means no P's are Q's. Okay, so no math professors are rich. If I draw this one, I can say, there are two sets of people. One is math professors. The other set is the rich people. So I can say, hey, these are the math professors. And here this set is rich people. And then I'm going to put you see that this point represents a particular math professor, has nothing to do with being inside this rich people set. So this is one example to if I have a statement like that, that's the graph that I'm going to draw. The next one is some P's are Q's. This gets a little more interesting. So it says some P's are Q. So here's the one possibility. This is sets P and this is sets Q. And do you see that I have to put the dots here to represent some P's are Q's? So some elements in P also in the Q, right? to represent this relationship, you certainly don't want to put the dots here. This means some p's are not in Q. When you want to show some p's are Q's, you certainly want to move these dots to here to represent that. And this is first possibility, and here's another possibility. So say this is P and this is Q, this inside one is Q. So do you see some P's are Q's, right? Some P are also in Q. Well, some people say, hey, what if you put a dot here? That means some P's are not Q. Well, we are trying to show that to draw some possibility that some P's are Q's. So we don't do that. This is the correct way to demonstrate some P's are Q's. And also, this can be another possibility. So Q is outside and P is inside. So P is inside. So in this case, definitely all P's are in Q's, but definitely that's true. But also, it is true to say that some P's are Q's because you pick some P and it's inside the Q. So now you can see that just for this particular statement, there are several different possibilities. That's why when you have kind of complicated scenario, sometimes it might not be a good idea to draw graphs because it can be difficult, sometimes can be confusing. So here some students have money in pockets. So here we have, say I'm going to draw the first circle represents students, and then draw the second circle to represent people with money, right? Money in their pockets. Okay, so now this is certainly one scenario. Some students have money in pockets, and then we can certainly draw the next one, which is corresponding to this scenario. So I'm going to say this is money in pockets, okay? Money in pockets. This outer one represents people with money in pockets, and the inside one is, say, students. So here you do see that some students have money in pockets, or this is can be this one, student outside, and then here inside is money in pockets, and this is another possibility to represent this statement. All right, the last one is some P's are not Q's. We kind of looked at this earlier, so to represent that. So this is the first possibility. This is P, this is Q, and see some P's are not Q's, right? Or this is another one, P, Q, and then you see some P's are not Q's, right? And here's the last one. Think about the last one. So before you resume the video, and then think about what would be the last possibility to show some P's are not Q's. Okay, so this is the last one. Suppose this is P, this is Q. Do you see that? Even though all of P are not Q, but that's certainly this is true. Some P's are not Q's, right? So this is the three possibilities, and this is one example. Some students in this class are not from Nebraska. So for instance, I can show that this is the first possibility. This is student in this class, and this is student from people from Nebraska. This set from Nebraska, the second set, and this is the first scenario, first possibility. And also here, if you want to say that so student here in this class, and the second one is people from Nebraska. Well, I feel like you really cannot use this because students in this class certainly not more than people from Nebraska. So this, I don't think this is applicable in this particular scenario. So this, I don't think this is applicable. This graph is appropriate in this situation. So because all people in Nebraska not contained in will not be contained in the set of students in this class. That's just not applicable. And certainly the very last one is certainly applicable. Here's the students in this class, and here's the set of the people from Nebraska, right? Nebraska. And here, this is certainly one valid demonstration of this particular statement. All right, so now we've introduced 4 possibilities when speaking of 2 sets. Now let's see, we are going to apply what we just discussed to determine whether the following arguments, each of those is valid or invalid. So the first one is all college courses are fun. So let's try to graph this, the first statement, and we do see 2 things, right? One is college courses. Second thing is fun things or fun courses, fun things. Okay, two sets. One set are in. So this is what we are talking about. All P's are Q's. So we have to make sure that it's this graph. So we are gonna draw that. So larger one is, say, fun courses, and inside this is the college courses, and then we are going to put the typical college course here to represent a randomly selected one and typical one. So that's the representation of the first statement. Now this is a college course. Well, actually I'm gonna say, now pick this, what the course that we are talking about now is inside here, right? Because it's one of the college courses. So we should now, let's say, suppose this purple dot means this course. This is the course. So it should be drawn inside this circle. And look at the conclusion. This course is fun. Definitely, because this purple point, which representing this course, is inside the fun course. So we can see that this is true. So this is a valid one. So just by visualizing such scenario, we can make a conclusion. And let's take a look at the next one. All poets are good spellers, and let's draw the sets. So here, good spellers is outside, is the larger set, and inside this smaller set is the set of poets. Okay, and now Susan is not a good speller, so therefore when you represent these subjects, right, Susan is not a good speller, so here Susan has to be outside, right, outside this good speller. Therefore Susan is not a poet, so therefore do you see that Susan is not a poet? This is true, right? So valid. You can see the relationship here through the diagrams. And let's take a look at the next one. No psychologist can juggle. So we have 2 sets. One is psychologist. The other one is people who can juggle. So therefore we are going to say, hey, this is psychologist. And here this is people who can juggle, right? Let me just use juggle to represent all the people who can juggle. Now, all clowns can juggle. So here's people who can juggle, and all clowns can juggle. So all clowns has to be inside. So clown, okay, because they can juggle, so it has to be inside. Now, no psychologist is a clown. So let's pick a arbitrarily chosen psychologist. So which is right there, right? Just right one. Do you see that it's not inside the clown, this set? Therefore, this is a valid argument. So valid. Right. So I think we have done a few, and if you want to pause and try the next one, very welcome to do that, strongly encouraged to do that. So let's continue. All human beings are mortal, therefore, here, this is creatures that are mortal, the outer one, and all human beings, because that should be inside, this is all P's are Q's. So here, this is human being, okay? Human being. And now take a look at the next one. Felix is mortal, therefore Felix is a human being. So Felix is a mortal. Some of you, here's a common mistake. Some of you argue, all right, by the way, this means human being. Let's make sure that human being. Okay, so some of you may argue, hey, let's put Felix here, and then therefore Felix is a human being. Felix is mortal, right? So Felix must be inside the model. Now you may feel like, so this is Felix. Okay, you may feel like, okay, this is true. Now, however, this is not the case, because of course this is one possibility. This possibility leads to this conclusion. However, in order for this to be valid, we have to consider all the possibility. Like here, human being. So if Felix is mortal, so Felix is inside this model, so we can certainly, this is one possibility, right? So Felix is here, and then you can see that Felix in this case is not human being, is not inside a human being, so therefore it actually is invalid. So here's the idea. Sometimes you may have scenario that's valid, but as long as you find one example that shows this is not true, then this argument should not be true. So in other words, I'm going to make a comment. This doesn't show the argument is valid. So it is important to recognize that. Now let's do the very last one. This can be a little complicated here. So all cars made after 1998 have driver side airbags. So I hope that you can feel like there are two sets we are talking about. The first set is the cars made after 1998. The second set is the cars that have driver side airbags. So here we have all P's are Q's structure. So therefore I'm going to draw two circles. The first one represents cars with driver side airbags. Okay. The second one is the cars made after 1998. So there were two different sets. And now some cars with driver side airbags have passenger side airbags. Okay, so here I'm gonna we already have this set, cars with driver side airbag, which means this circle, so we do not need to redraw a different circle, which is this is the circle represents that one. But we do have another, we do need another circle in another set, because we have here cars with passenger side airbags, right? So therefore I'm gonna draw another circle. Well, I'm gonna put this circle, I will move this circle around, okay? So this circle means the cars like with passenger side airbags. Okay, and then airbags. Now I'm gonna and let's look at the conclusion. Some cars with passenger side airbags, which means one element from here, are made after 1998. So two sets. One is a car with passenger side airbags, which is this guy, made after 1998, which is this guy. So I'm gonna some car. So this is the some car with passenger airbags, right? So I'll begin to move. Okay. So now here, if you see this scenario, you will see that some cars with passenger side airbag are actually not made after 1998. So by looking at that, we can see not valid here, not valid, right? Not valid because it's not inside the cars made after 1998. So again, if you feel like I can continue to move this inside and you move this circle inside, which shows, hey, there's some possibility that's made after 1998. Well, again, this doesn't show this argument is valid. Just like here, this doesn't show this valid because you find another one that shows it is invalid. Therefore, it is invalid. Therefore, we can use this to show the invalid. All right. So this is it for this particular section.